So in the today's video, we are going to talk about a new topic, which is nothing but hash table. Okay, hash table data structure, which is nothing but sometimes we can use the word called hashing. Sir, what is this hash table data structure? Sir, very simple. Hash table data structure, do you know, in general, first let me give introduction for this. In general, sir, what will happen in the normal case? Okay, so in the case of searching algorithms, what will happen? Consider a problem we are searching. Consider a problem we are searching for an object. Okay, we are searching for an object in 100 objects. Okay, I have target of 100 objects. In those 100 objects, we need to search for an object. Okay, so if the object, okay, if the objects are not sorted in any order, so then we will search. Okay, we will search continuously. We will search continuously, one by one. So called as linear search. How much time it is going to take? Sir, big O of n it is going to take. Big O of n means what? Sir, starting from the first element to continuously we are going to search for n elements. Sir, please wait. Right. So it is nothing but how much time complexity is going to take. Big O of n. Sir, if the objects are already, okay, if the objects are already in sorted order, if the objects are already in sorted order, then then we can apply, okay, we can apply binary search. We can apply binary search algorithm. Sir, how much time it is going to take? Big O of, okay, big O of log n it is going to take. Means what? Something like dividing. So searching operation like that, almost half of the time we are going to reduce. But there is one concept is there. So it is possible to get, okay, it is possible to get the location of a given key by using some magic methods. Okay, by using some magic methods we can able to directly give the location of the given object. Okay, sir, almost it takes linear time. Sorry, not linear, constant time. Means what? Something like big O of 1. Okay, sir, do you know? So big O of n, which is nothing but very large when compared with big O of log n. Okay, and which is very large when compared with big O of 1. So almost with the constant time we can perform search operation. If you are taking big O of n for searching purpose, it is called as linear search operation. If you are taking big O of log n, it is going to take binary search. It is going to take binary search. So if you take big O of 1, then it is going to take almost constant time. This search operation is nothing but what? Hashing, or we can able to call it as a hash table, or it is called as a hash function. By using this technique we can able to reduce the searching time. This is nothing but what we have. Okay, I think the introduction for the hash table, it is very clear for you, right? Any doubts up to this? Please confirm.
So this is the same concept which tuple is having, right?
Sir.
This is the same concept which tuple is having, right?
Yes, sir.
Mm.
Not a tuple, sir. Dictionaries are having these kind of things, not a tuple. Tuple also going to follow some other sorting technique internally. I mean, some other searching technique internally. Okay. So there are some problems are there in this hash table. That's why we are not going to use this regularly. Okay.
But
Right.
one class of Durga sir, he told about when he was telling about difference. So he told that tuple is hashing concept is there in tuple, so that's why it is.
Everywhere it will be there, but the problem is depending on the number of objects it is going to change. You can see from this class we can't conclude that. So for searching operation, if I use if you store the data in hash table, it is going to take a constant time. No, for only certain small case of inputs only it will work.
Oh.
Actually it is a deprecated concept, we are not going to use it, but internally sometimes we are going to use in some special cases.
Mhm. Okay.
Okay, for identifying the objects we are going to use these kind of things.
Yes, yes, okay.
Okay, right. So coming to hash table, what is mean by hash table? So let us talk about this hash table. Sir, what is mean by hash table? Very simple. So hash table is a data structure, that maps keys with values. Okay, otherwise that maps keys to values. Each position, okay, so each position of the table is called as a slot. Okay, a slot, or we can call it as a bucket, or we can call it as a record, like that we have. Okay, so each position of the table is called as what? Slot. Every position in the table is called as what? Slot or bucket, or it is called as record. Okay, and how these things are going to be identified? This hash table uses hash function. Okay, hash table uses a hash function to calculate the position of object. It is used to calculate the position of the object, where we need to place the object. That can be identified by using this what? Hash function. Okay, sir, now I will explain the process of storing data by using hash function. Sir, how you can able to store? So in the hash table is as follows. Sir, how you are going to store? First we have to create an array, or we have to create a list of size n. With how many elements we have to create an array or list? N elements. So this list is called as hash table. This list is called as what? Hash table. Sir, parallelly I'm going to take some example. So you can see here I have a paint here like this. Now you can able to see. Sir, consider I'm going to take a hash table with how many values? Sir, maybe with 10 values I'm going to take the hash table like this. So 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like this we have. So what is the size of this hash table? Sir, the size of this hash table is not, sorry. The size of this hash table is nothing but, one second. Yeah, right. Sorry for the delay, sir. So this is called as what? I created one hash table here. Okay, I created one hash table. This is called as what? So hash table. Okay, so it is nothing but what we have here. Sir, now my requirement is first step got completed. What is the second step here is we have to find hash code. We have to find hash code of the object. We have to find the hash code of the object by using hash function. Okay, by using hash function we are going to find hash code of the object, sir. By using hash function we can able to find hash code of the given object. For example, consider, for example sake I am taking, sir, I am going to take one number. For example, I want to insert one object. Let us consider that object is nothing but 127. So the indexes of this hash table will be like this. Now we have to calculate what is the hash key of this particular object. How you can able to find out? There are n number of approaches are there. The first approach is we will divide that number with the percentage 10. Okay, if you divide that number with the percentage 10, you are going to get the remainder, right? So what is the remainder? That we got 7. That means we need to place that object in 7th location. Like that we are going to get. You may have a doubt, sir, if any other object is coming with last digit as a 7, what will happen? That is a secondary approach, sir. I will explain, don't worry. But as of now, we have to find out a hash code of the given object by using which function? Hash function. How to calculate a hash function? We have to take so modulo division. We have to take modulo division of the given object. Okay, of the given object with a table size. Okay, with the table size. This one is nothing but what? Hash function. We have to take modulo division of the given object with the table key, table size. For example, sir, I want to take, sorry guys, 1 second. Right, sir, we are going to take h of key. I am going to calculate hash function is nothing but, sir, what is the code for this? We have to divide that object content with table size. Like this we have. Previously I want to find out the hash code for 127, which is nothing but what? 127 percentage 10, which is nothing but 7. That means we have to place, we have to place this 127. Okay, 127. Okay, in which location? 7th location. So we have to place this 137. We have to place this 137 at which location? At location 7. Like that we have. Okay, sir, next fourth one. Finally we have to store, finally we have to store this object in the position, in the position returned by, returned by hash function. Sir, what value returned by hash function? We have to take this value in that. Sir, I request everyone to please confirm, is the process of placing the hash, the process of placing this one, is it clear for you people? Please confirm, is the process is clear?
Yes, sir.
Yes, sir.
Then, sir, what are the common operations that we can able to perform on a hash table? So what operations we can perform? The first one is nothing but what? Insertion operation. Second one is nothing but what? Delete operation. Third one is nothing but what? Displaying the content in the hash table. And the fourth operation, which is very very important, called search operation. Like this we have. Sir, I will explain the implementation of this particular program. Okay, there are multiple ways are there. The first one, implementation of hash table. I want to take one example to define this implementation. Let us take one example. Okay, I am going to implement a Python program for this. Let us see. Right. Have a look once. Sir, I am going to define a class called hash table. In this class, I will define a constructor with how many elements, self comma size. Now I am going to take self dot size is equal to whatever size that you have given, and self dot I am creating a list with initial values as a -1. Why I am taking -1 in the sense, listen carefully. Suppose if the given object is 120, where we need to place this object? If you take 120 percentage 10, you will get a 0. That means in the 0th location we have to place, right? So you may have a 0 or something like that. So you may have a 0 also, right? 0 is also a valid object, right? That's why. So to avoid that, I'm going to take which value as the default value? -1. Like that, I have taken a constructor. Next, sir, I want to print this list. I want to print. So I will take the function called print. So I am going to take self as the first parameter. So here I will print the message saying hash table content. Okay, hash table content I am printing. Sir, we have to print. How many values are there? So we know the size, right? So until that self dot size, I am going to print in a formatted string saying, so that index value followed by which value is located in that I can able to print. This is nothing but how you can able to print the list. Like that we have. Sir, initially I will take one hash table like h is equal to hash table of 10. H dot I want to print. Initially, is there any elements? No, right? Now what will happen? Sir, every element is initialized with -1 default. Like that we have. Okay, every element is initialized with -1. Sir, I want to add some value. But before that, we have to define hash function, right? I am going to take a function like a compute, which is going to take self comma value, and I want to return value percentage self dot size, that means what? Whatever value that you are giving, I am going to divide with the table size. Whatever remainder that we are going to get for that object, that is nothing but the key. This compute function is going to return this particular value. Now I will implement add function, which is going to take a value or an object. We have to check hash code for this. How to calculate hash code? Can I call compute function by taking the value as the input? Now see what will happen. Sir, here if I want to insert the object like 129, so that will become value. Hash code for this is nothing but what? We are calling compute function by passing this value. Then immediately what compute function is doing? Value percentage size. Sir, your value is 129. Percentage size means 10 elements. Assume like that. What output we will get? 9. So in the hash code, which value is there? 9 is there. Now we have to check, is that ninth location is empty or not? How to check? Sir, self dot list of hash code is equal to -1 means what? Yes, there is a vacancy position. Sir, in such cases, L of your hash code will become the value which you want to place, and then return true saying successfully we added the element. Otherwise, that means in that place, if already object is there, then your hash code value is not -1, right? In such cases, it is going to return false. That's all. Simple operation. Now I will execute this code by adding some objects. Okay, sir, now what I am going to do is I am going to take h dot add of 123. I'm going to take h dot add of 125. Sir, I'm going to take h dot add of something like 777. Now I want to add, so 789, like this. Sir, total how many objects we added? You can see 3 objects. Sir, 123 is added at third location, 125 is added at fifth location, 789 is added at ninth location. Sir, better whenever you are adding, try to capture the written value. The reason for that is nothing but if it is returning true, then we got an acknowledgement saying that the element got added. If you are getting false, then it is an acknowledgement saying that that element is not added. Sir, for one value it should return false. For that I am going to take so another one, 787. Sir, now you can see, sir, what output we got? False, because that object is not added. The reason for that is nothing but what, that position is already taken by some other object. Like this, we can take the combination of compute function and add function to store the values into the hash table. Sir, everyone please confirm, is the concept is clear up to this whatever we covered?
Sir, self dot L is equal to -1.
Sir,
The statement. Self dot L is equal to fifth statement, sir. Fifth statement.
condition. Now what is your doubt? You have the doubt in 17th line, right?
No, sir. Fifth statement, sir. Fifth statement.
Fifth
Fifth
statement.
state. Yes.
You have a doubt in the fifth statement.
Yeah.
Simple, sir. You know very well about Python. In Python we have a list concept. So list is fixed size or variable size? Variable. That means we can add any number of objects, right? Am I right?
Yes.
But according to hash table definition, we are going to fix the size, right? Are you getting my point?
Yes.
We are going to fix the size. You can see create an array or create an array or list of size n. This is nothing but a hash table, right? Hash table means definitely it is going to have some limit like 10 elements, 15 elements, like that. Got it?
Yes.
That is the reason why I am taking like this. If you take -1 into size, suppose if size is a 10, it will create a list with how many elements? 10 elements. All the 10 elements are nothing but what? -1. Got it?
Okay.
Of course we can add the objects into this list, but we are not going to do. We have written it in such a way that we want to write
Something like negative indexing.
yes, and not negative indexing. -1, why I am taking -1 in the sense, see, 0 is also an object, right?
Yes, sir.
So that's why, because list index is going to start from 0. That is the reason I am going to take -1 as the default value. Even you can take none also, no problem. But if you take
-1 is the value.
0 into size means what?
0.
It is going to create a list with 10 elements. Every element value is 0. Maybe I'm going to feel that 0 is nothing but a value, object, something like that. Okay. Clear, sir?
Okay.
Right. Now we have to perform remove operation. So something like delete. Self comma, we are going to give the value. We need to delete this value. Whatever value that you have given, for that I am going to calculate hash code. Whatever value that you have given, for that I am calculating hash code. So if self dot in that particular position, if -1 is there, okay, if it is not equal to -1, that means what, that location is there. But we need to check the content also, right? So self dot L of, so whatever hash code that you have, that value should be matched. If both are same, then self dot L of your hash code will become -1 and then return true, saying the deletion has been completed, otherwise false. Sir, I will explain this code, listen carefully. Suppose if I want to delete an object called something like in this table we have, right? Suppose consider I want to delete an object called 127. So if you want to delete 127, what I am doing is, First I will calculate hash code. What is the hash code? Which is nothing but 7. So we got a hash code as a 7. So is self dot hash code is equal to -1, is not equal to -1? Yes, it is not equal to -1 because there is a content. So if content is there, but it is not guaranteed that only that element is there, right? How you can check? Self dot hash code is equal to, if it is having this value, then so element is there, that location is also filled. In such cases we are going to make that element as a dummy. Means what? In that location we are going to take -1 and we are going to return true, saying that element got deleted. Suppose if the element which you are trying to delete, we calculated the hash code, unfortunately that hash code content is empty. In such cases what will happen? We can't perform delete operation. Simply I am going to return false. This is nothing but what we have. Now same example I am going to take. Sir, I will try to delete. So print of h dot, can you please delete 777? Sir, is that object is there? Yes, compulsory it is going to delete. If you want, you can see. So the output which we got is true. So initially in the 7th location 777 is there, but now in 7th location 777 is not there. Now I want to delete, so the element with the content 222, okay, or 333. Sir, please listen carefully. It is going to return false. 333, what is the hash code for that? 3. So 3 hash code is already filled with some element, right? But that element is not 333, right? In such cases it is going to return false. So if you want, you can able to see. You can see, sir, it is returning false, right? Yes, this is nothing but what we have. Sir, similar to this, let me talk about search function also. Search, I am going to take a self comma value I am giving. So hash code is equal to, hash code is equal to, I am taking self dot compute of, first I will calculate hash code for that. Now if self dot l of that hash code value is equal to the given value, we are going to return true, that is element is available. Otherwise we are going to return false. Very simple operation. Now after this I am going to take h dot, can you please search for the element called 123? Sir, is it available? Yes. Now I want to search for 124. What output we are going to get? It is going to return false. If you want, you can cross check how it is going to work. This is the way how we can able to implement hash table data structure. Sir, I covered sample implementation, but there are some problems are there in this hash table. I will explain, don't worry. I think the basic implementation of hash table, it is very clear for you people, right friends? Please confirm, clear?
Yes, sir.
Right. So the next one what we have here is, we are going to talk about next level concept here. There is one concept is there with name collision. There is one concept is there with name collision. What is mean by collision? Sir, when, okay, when a function, when a function generates, when a function generates the same index value or the same hash code for two or more objects, for two or more objects, if a function is going to take same index, so then it is a very difficult, okay, it is a very so difficult, it is very difficult to store, it is very difficult to store that object into the hash table. It is very difficult to store that value into the hash table. So in such a cases what we are going to do? Collision. So collision will occur, okay, collision will occur, collision will occur, okay. So we have to write, one second. right? So here, when collision is going to be happen, sir, when we are going to take more than one object, for multiple objects, if it is returning the same hash key, then collision is going to occur. Okay, so we have to write a hash function, we have to write a hash function effectively or efficiently, so without collision. But is it possible? Without a collision we have to prepare, but practically it is highly impossible, we can't able to take like that. Okay, but we have we have some collision resolution methods are there. What is the first one? Linear probing is there. Second one is nothing but what? Quadratic probing is there. Okay, third one we have separate chaining is there. By using these three techniques, we can able to resolve the collision. But how you are going to resolve this, I will explain with the help of examples. So implementation of linear probing, sir, how you are going to implement this linear probing? I will take one example and I will demonstrate. Can you please confirm what is mean by collision, how this collision is going to be happened? Is it clear for you people? Please confirm. Clear up to this? Right, sir. Now here I am going to implement same program, I am going to take, but I will change the objects. Sir, here you can see, I am going to add some objects here. Which object I am going to add is, so print of h dot add of 3 I am taking. Sir, is that object is going to be added? Definitely it will add. Now I want to add 13. Is this object going to be added? Definitely it won't add, because it is going to return the same key, right? That's why the output what we are getting is false. We can't able to insert that object. Sir, in such a cases, what we can do? Very simple. We have to modify the hash function in such a way that it should able to entertain that. So for this, I'm going to apply one technique which is nothing but linear probing. Sir, in this linear probing, what I'm going to do is, in addition to this particular function, I'm going to define another compute function which is nothing but a compute one. Okay, compute one. So what it is going to do is, it will return, we are going to give some index value for this, it is going to return that index. Means what? Sir, from the diagram you can see, first I will try to place the object. Suppose consider the object which we got is 333, we will place at third location. If sir 343 is coming, we will look for the next place. Linearly we will move one by one and we will search. This is called as what? Linear probing. For that linear probing, if you are giving any index, it will return that index. Sir, we have to change the add method. How we are going to change? Sir, 1 second, please wait. Yeah, right. Sorry for the delay. You can see this compute one is going to return index value. Sir, how to add the object? First, we are going to calculate a hash code by using the general method. Now, what we are going to do is this entire checking process I am going to take by using a loop for each I in the range of self dot size. Okay, I'm going to take one loop which is going to take the values from 0 to size. Sir, we are going to check if a self dot L of hash code is equal to -1. That means if the vacant position is there, so in that particular position, okay, try to take the value, then we have to return true. Okay, fine. If that is not vacant position, we have to search for alternative, right? So your hash code will become already available hash code plus self dot compute one. We are going to pass that value of I. Then your hash code will become what? Hash code percentage self dot size. Like this, we are going to take. And still, if it is not working, we will return false. But anyway, I will demonstrate this code how it is working. Please focus very clearly. So I'm going to demonstrate this code, this entire add function, how it is working. I'm demonstrating. Sir, please listen, this is very important. Consider the first time I'm giving the value as a 3. What will happen? We are going to call compute function by passing the value as a 3. What is the hash code for this 3? We got 3. Sir, is the third location is empty? Yes. In third location, it is going to take 3. Okay, perfectly filled. It will come out from this. Now I'm giving the object as 4. Sorry, 13. So what is the hash code for this? We are getting 3. Sir, in that third location, is it empty? No. So what is the value of I first time? Your I value will become 0. In this case, the element is already available. That's why I am recomputing the hash code. What is the new hash code? Already available hash code is 3 plus what is the I value, sir? That I value it will return as it is. We are adding that I, which is nothing but 0. Sir, what output we will get? 3. Sir, is that third location, is it empty? No. Then next time the loop is going to run for I is equal to 1. In such a case, what will happen? Hash code is equal to previous hash code is 3. So plus what is the current I value? 1, which is nothing but 4. Try to check fourth location. If it is empty, place that value. That is nothing but 13. So then if I want to insert for 23, sir, third location is filled, fourth location is also filled. Then for I is equal to 2, it is going to take. This is nothing but the updated formula. Sir, why you are taking this? For example, in this example, third location, fourth location, like this, we are keep on inserting up to 9. Still, if you have any elements, but our hash table is not filled, right? In such cases, what will happen? We have 0th location, first location, second location. To get that, we are going to divide the hash code with the table size so that it will circulate like this. How many times total it will run? 10 times it is going to run. This is the technique what we are going to apply in the linear probing. Sir, here the main formula is nothing but this one. Linear probing means what? If the value is not able to insert, we will search for the next location. Like that we have. Sir, everyone feeling comfortable up to this? Everyone feeling comfortable up to this? Please confirm. Clear? Right. Sir, we need to update. Okay, we need to update remaining functions also. Can I take the same function for which operation? Delete operation. I am taking same function. Sir, first we will calculate a hash code for I in the range of self dot size. Sir, if what is the previous code that we have taken for deletion purpose? This condition we need to take as it is here. So if self dot hash code is equal not equal to -1, sorry, equal to -1, okay, and self dot hash code is equal to value. I think it is not equal to -1, right? Not equal to -1, and that hash code value is present. In that value, which one we have to replace? -1 and return true. Otherwise, try to search in the remaining locations. Like that we have. Sir, what about the search function? Search function is also same. In this case, we are going to take hash code if that L of hash code is equal to the value which you are searching. So then what we are going to do? We will return true. So otherwise, we will search in the remaining locations. Now let us cross check. Is this 13 got inserted or not? Definitely it is going to be inserted in fourth location. Now I want to insert 23. I want to insert 33. I want to insert 43. But there is no guarantee that every time it will add. There may be a problem. Yes, up to this it is added. Various cases will come. You can cross check later. So 53, 63. Okay. Let me cross check. Sir, have you observed here? One false case we got. So 53 got added. For 63, the collision is occurring. Even though you are continuously traversing, it is not possible to insert this 63. So there is a problem with linear probing also. To overcome the problems with linear probing, we are going for which one? Quadratic probing. So instead of going sequentially, can you please go in the double by taking the double values? We can able to go. Sir, let me take that program also. After that, we can go for separate chaining. Sir, in the quadratic probing, what we are doing? The quadratic probing is a simple approach. The only modification which we need to do is we have to take another function like compute 1. I am going to define another function called what? Compute 2. In this case, instead of returning index, I am taking index into index. So every time, instead of calculating compute 1, try to calculate compute 2. Like this we are going to take. That's all, sir. Now let us see, is that element is added? Definitely no. You can see in the linear probing we are getting error at last position, but in the quadratic probing at the beginning itself we are going to get. So there is no guarantee, but just I am giving, it is nothing but something like alternative solution. So I think you people got a very clear clarity how this linear probing and quadratic probing is working. It is a completely mathematical formula. Sir, everyone feeling comfortable up to this whatever I covered?
Yes, sir.
Right. Sir, last one in this, which is nothing but something like separate chaining. We are going to take a linked list in this. Let us see implementation of separate chaining, how it is going to work. Let us take one example. Sir, from the beginning we have to take, so hash table I am taking. In this we have to implement by using linked list. Class node will be there. I am going to take init underscore underscore self comma value comma, next field is by default none, and self dot value will become the value which you are giving. Self dot next field will become the next field what we are giving, and we are going to define hash table. Okay, and with some size. So self dot size will become the size what we have, and self dot L is equal to, so here I am going to take none because we are working with the objects, right? That's why. So none into, we are going to take a size. It is going to create one empty list with how many elements? What is the size of hash table with those elements? So something like we will create like this. So first index values will be like this: 0th index, first index, second. These are values. If you want to insert 11, it will be added here. If you want to insert 21, it will be added here. Have you observed? Something like a linked list it will attach. So there won't be any collision in this case. So here we are going to declare a list like this, and I want to print the list. But we know already how to print the elements in the same approach we have to follow here. So print of, I am taking hash table content. Sir, how to print hash table content? I am going to take for each I value in the range of, okay, in the range of self dot size. So I'm going to print in a formatted string saying that I value, okay, I value followed by, sir, very important. We will get a linked list here. That's why I am taking end is equal to space. Continuation linked list will be there. Sir, temp is equal to, I am going to pointing to the first node which is available. Okay, temp is equal to, I am going to pointing to the first node which is available. Sir, we have to keep on checking the nodes until the temp value is not equal to none. We have to print temp dot value followed by end is equal to something like this. I am going to print, and the temp will become what? Temp dot next. It is displaying the elements present in the linked list. It is nothing but displaying the elements present in the linked list. Sir, as of now, I will create one hash table. So h is equal to hash table. So h dot I am going to call print method. But as of now, we don't have any elements. But here we have to give the table size. Let us take the table size as a 10. Now you can see. Sir, here in the place of none, it won't store a single value. It will take a group of values in the form of list. That we have to implement now. Sir, up to this driver code, is it clear for you people? Clear, please confirm. So now we have to see how you can able to add the elements. For that, we need to go for add method. So how add method is going to work, I will show you now. So how you can able to take add method, I will explain. Okay, let us take def. I am taking add. So self comma, we have to take the value which we need to insert. Now I will calculate as usual hash code, but before that we need to write that hash code function also. Def. So compute function I am going to take. So which is going to take self comma value. Okay, and it is going to return value percentage self dot size of the table. Now we have add method is there. From that I am going to calculate a hash code. Hash code is equal to self dot compute of, I am going to give the value, corresponding hash code will come. Self dot L of hash code will become, I am going to create a node with the given value, and the next field will become L of hash code. Like that we are going to attach. So if you want you can see, but as of now we didn't added. Now I am going to add some content. H dot add of 23 I am adding. Sir, now see where it will be added. Sir, in third location 23 is added. Now I want to add 33, I want to add 43, I want to add 99. Sir, all these objects will be added. If you want you can see in the style of linked list. 43, next node is 33, next node is 23, but unfortunately it is something like adding at first. Always it is adding at the first location. This is the way how to add the objects into the linked list, where we are applying separate chaining principle. Sir, everyone feeling comfortable up to this? Right. Sir, we will see how delete function is going to work. Self dot, sorry, self comma value I am taking. First, as usual, we will calculate hash code for the given value. So we are going to take that value inside some temporary variable, because at last we have to return that value. Sir, after that, if your temporary value is not equal to none, at the same time temp dot value is equal to the value which you have given. In such cases what will happen? So L of hash code will become, so temp dot next, and then we will return true. Sir, it is something like, if head element, if head element is a value, then what will happen? That means the element which you are trying to delete is available at the first location. Sir, in such cases what will happen? We have to take the next node as a head, and we have to remove the control. If you see the example here, Suppose if I want to delete 43, sir, 43 is the first element, right? So that next element will become in this place. That is nothing but what we have. Sir, it is not available in the first element. Then what we have to do? Until your temporary value is not equal to none, so you are going to take temp1 is equal to temp dot next. And if temp1 is not equal to none, we are checking the next node. If it is not equal to none and temp1 dot value is equal to the value which you want to delete, in such cases, so temp dot next field will become what? Temp1 dot next. That's all. Directly we are going to return true, saying that element got deleted. Otherwise, the temp will become temp1. We are keep on searching till the end. But you never encountered means we will return false. That's all. Sir, for convenient purpose, I am going to take print of h dot. So delete of 23 I am taking. Sir, is it going to delete that 23? Sir, 1 second. Somewhere we have taken single equal to. We need to take double equal to for the comparison. Hash table dot compute. You can see, sir, is that element got deleted or not? Yes, you can see. Sir, if I want to delete 43, it is something like the element which is available at very beginning. Sir, is that 43 got deleted? Let me run. You can see that one is also deleted. Like that we can perform delete operation. Sir, search operation is also almost same. So in the linked list we implemented search operation, right? In the same way you have to do here. Sir, how to search? First we will calculate hash code for the given value. How to take? We will call compute function by passing the value. Then we are going to take self is equal to self dot L of hash code. That link we are going to get. And until the value of temp is not equal to none, we are keep on checking if the temp dot value is equal to value. So then we will return true. Sir, otherwise what will happen? Temp will become temp dot next. This process will continue. At last it is going to return false. Now let us call search function. Sir, I want to search for the element called 43. Is that element is available? Yes, the output what we got is true. Okay. Now I want to search for the element called 93. Is that element is available? No, we are going to get false. Like that we have. So this is the way, by using linked list, how we can able to implement hash table. Sir, everyone feeling comfortable up to this? Clear? Right. This is nothing but hash table data structure what we have. Okay. Sir, tomorrow we will meet for the continuation. Tomorrow also same timings, sir. 6 o'clock you have to join. I will start a tree data structure in the tomorrow's class. Okay. Right, sir. Thank you. I will upload the running notes within few minutes. You can able to download. Okay. Thank you, sir.